Hello students, welcome back. And today we are going to deal with matter in our surroundings, a subtopic of it, that is evaporation. Okay, so you might have already been, aware of this term from your previous classes. Okay, so evaporation, you have seen, maybe in real life, you can think of examples, like for example, the wet clothes. Okay, so we people like to keep it under sun to do it sun dry, basically, right? Try to do it sun dry. Okay, now once we start sweating a lot, we run a lot and then we sweat. Okay, so we start getting the cooling effect on our skin, or if you turn on the fan or AC, you'll feel more cool, right? You'll feel more relaxed, and the temperature will feel like going down, right? So today we'll study all the secrets behind how that is happening. Okay, or what are the phenomena which are involved in these cases. Okay, so what exactly evaporation is? Evaporation is the process where the liquid particles, so again, when I'm talking about liquid particles, let's recall our particle arrangement. So it would be something like this, right? Liquid particles on the surface gain enough energy somehow to transform themselves into the vapors. Okay, like this. So this is a liquid state, right? Getting converted into gas, and it has gained certain energy, some sort of energy. Okay, at any temperature below boiling point. Now this we have to keep in mind. So see, it's not going to be, the liquid is not going to be converted into gas at 100 degrees Celsius, and the water is not going to bubble up and boil and all, right? It is gradually being converted into gas at any temperature. So first thing you have to keep in mind, see, there is difference between boiling and evaporation. Okay, you will say, ma'am, boiling is similar to evaporation. Why are you saying they are like two different terms? So in boiling, what is happening? First of all, it happens at 100 degrees Celsius. Second, you'll see a lot of bubble also, right? When water is boiling. And then what exactly happens here in boiling? The liquid is getting converted into gas, but at a particular temperature. Okay, but in evaporation, you will see that the temperature could be any temperature. Okay, it can be 50 degrees Celsius, it can be 20 degrees Celsius, right? At any temperature, evaporation can occur, and it is a continuous process happening all around us. So all the time when the sun is there, okay, evaporation is happening, okay, around us. It doesn't have to be 100 degrees Celsius and boil us. The sun doesn't have to be 100 degrees Celsius, right? So it can boil us. No, but it is supposed to be happening. That's why boiling needs 100 degrees, right? But evaporation is happening around us all the time, like you are drying your clothes, right? Or maybe if you're keeping water in a pan or something outside, maybe in a hot summer, you'll see it's all gone. Okay, nobody drank it, nobody went there, but it's all gone because at certain temperature or at any temperature, it has got converted into gases. The liquid has got converted into gases. Okay, now this is a surface phenomenon. Only particle on the liquid surface escape as vapor. What do we mean by that? So suppose this is your cloth. Okay, so the particle, like cloth is like this, right? Made up of lots and lots of threads and yarn like this, right? So in between that also there is space. That's why the clothes are breathable, right? You can, it's not suffocating. Okay, you cannot wear a metallic cloth all day long, but you can wear a cloth, fabric cloth, right? So those fabrics have spaces between them. Once you wash them, those spaces are filled with water. Okay, even the threads are filled with water. Now the surface of this cloth, once it starts having gained enough energy, the water will start evaporating and escaping and getting into turning into a vapor. And that's why this is a surface phenomenon. Like I told you, this happens below boiling point, happens at every and any temperature. Okay, even at room temperature, unlike boiling. So even at this temperature also, evaporation is right now happening. Okay, the wet clothes dry because of evaporation. The sweat disappearing from the skin. So even if you are having a lot of sweat, and you do not wipe it off, what happens after a certain point? It will be evaporated. Or even if we wash our face, what we do is sometimes, or maybe we wash our hair, okay, and we try to we dry it a lot and a lot, and we are, let's say, not using a blow dry here, okay, so after a certain point we leave it like that, right? But the hair is drying, right? That is because evaporation and not boiling. What if it would have been boiling? Then you can't imagine, right? So evaporation is happening in such daily life processes, okay, or you can say scenarios. Now, I have explained a little bit already. So evaporation versus boiling. Boiling is like a crowd rushing out of a concert, while evaporation is like people slowly leaving one by one. Okay, this will give you a better idea. So imagine you went to a concert or any kind of place where there is a lot of crowd and a lot of rush is there. Okay, a lot of people are there. So big crowd. Now, I announce that, okay, you may leave now. So if people start and leave, standing and leaving one by one, or let's imagine a examination hall, okay. So if you start leaving one by one, that is evaporation happening gradually, continuously, okay. But boiling is like everybody rushing out through one door, at a time, and crowding. So particles here are like rushing and fighting and all, right? Here particles do not fight. They gradually just become into gases. Okay. So let's see the properties and then compare these two. So where does it occur? Evaporation occurs only at a surface level. Okay. Boiling occurs throughout the liquid. So evaporation is like, suppose if something is kept here, right? So evaporation, like let's say water, first layer, second layer, third layer. Let's say 3 layers of water. So it will occur only at surface level. Not all the ocean water is going to evaporate. Not all the pond water is going to evaporate. No, it will happen at a certain, level. Why do lakes get, dried up in summers, in hot summers? Not lakes, pond. Okay, lake is much bigger thing. Pond is small. So the pond sometimes, near my place, there is a pond. So it gets dried up in summer and filled up with water in monsoon. Okay. So what happens is that the surface level water evaporates. Okay. Then again, let's imagine the second layer and the third layer, right? First layer is gone. Now, second and third layer. What happened? The first week, this evaporated. The second week, this started getting evaporated. Okay. Third week, third layer, which was left, would be gone. So like that, the whole pond would be left, dried. So that this happens at a surface level. But boiling is like, this is happening throughout the liquid. That means if you are boiling water, this boiling happens, actually the particles will be moving. This one will be moving here. Okay, then this one will be moving here and like crowding here and there and rushing out and exiting it as a gas. Okay, now temperature. At any temperature, this can occur, evaporation, okay? But it should be below boiling point. Once the boiling point has been reached, that is 100 degrees Celsius, right? So then what happens? Basically, the water will boil up and get converted into steam. Now, speed. What is the speed of evaporation? It is a very, very slow process. Like I told you, your weeks and weeks can take, right? To dry up the pond, okay? But here in boiling, if you will see, you'll notice that the whole thing will get dried up within few minutes or hours, you can say, okay? So because the temperature is so high, and boiling happens throughout the liquid. So it is supposed to get dried up easily. So this is a very, very fast process. Now bubbles I discussed with you, right? In evaporation, there is no bubbles being formed. But in boiling point, you will see the bubbles are being formed. Okay. So here you will see, not boiling point, sorry, boiling. So here the bubbles will be formed like this. Once you are boiling the water, you might have noticed. And then these bubbles gradually gets converted into gases. Okay. Here you will not, like from example, okay, let's not take example of a leaf. That would be wrong. Okay. Okay. So let's take a lake, okay, or a pond. We'll stick to pond. Okay. So what happens? The sunlight or the heat from the sunlight is reaching out to the first layer. And here it will gradually get converted into, you have never seen a pond or lake or anything, boiling up, right? Because for boiling up or bubbling up, for bubbling up, it needs to reach to the boiling temperature, which is not being achieved, and which has not been achieved so far on Earth. I mean, and since we are living. Otherwise, I don't think it's possible for us to survive, right? I guess you can imagine that. Okay, so factors affecting evaporation. There are totally 5 factors that can affect evaporation. The first is temperature and surface. So temperature, again, you can imagine the higher the temperature would be, the more energy. Now, the energy, when we are talking about of anything which is moving, it has some energy, and that energy is called as kinetic energy. Okay, if I'm not moving, I'm sitting like this. Okay, right? Not moving. Right? So that has, that time I have potential energy. Okay. And when I'm moving here and there, showing some action, that means there is kinetic energy. So what happens, the higher the temperature means the particles have more kinetic energy. Like we have discussed, particles get energized, right? And they start moving here and there, leading to a very fast evaporation. So again, you can imagine on a surface level, if the temperature is high, the particles will move. And once they start moving, they will start getting converted into gases. Okay. So example here would be clothes dry quicker on a sunny day than compared to a rainy day, or maybe days in winter. Okay. So why do puddles dry faster in May than in December? So that you can, again, connect with the temperature. Now coming to the surface area. Okay. So the larger the surface area would be, it will be more exposed liquid would be there, right? So suppose this is one area where the water is there, okay? And this is one big area, right? So at a time, like if the sun is there, okay, let me just make a sun. Let's make a smiling sun. Okay. Okay. So if sun is there and, same amount of heat is reaching both the areas, right? So here only sun would be able to dry this much, the top layer, right? The surface. So here the surface is small. So lesser, you can say evaporation will be in case A compared to case B, because there is more area exposed to cover, right? So again, more area exposed to cover. So more evaporation will occur in that. So a larger surface area exposes more liquid particles to the air, allowing more space, more escape, basically. Example would be water in a plate evaporates faster than in a glass. You can imagine, right? Because only top layer is going from evaporation, right? Spreading wet clothes help them dry faster. So suppose, imagine you are having a bunch of clothes you have washed, right? And if you kept it like this, so that is not, even if you are keeping it just like this, bundled up, in the sun. So some parts of it won't dry because the drying is only on the surface level. The evaporation is only on the surface level. So rest of it will stay wet. It will stay wet, right? But if in the case of, if you spread it, that's why we are, drying the clothes by spreading it on a thread maybe, or on a wire or a rope, right? So then what happens? So they dry up faster. Now to dry them quickly, spread it out. That's what you can do. And sun drying clothes is actually good because it keeps you away from a lot of diseases, which we'll study in biology maybe. Okay, the fungal diseases basically. Now coming to the third factor of evaporation. Okay, that is humidity of air. Now what exactly humidity? Students get confused between this. Okay, imagine atmosphere around us. I am sitting here in this room. Okay, or you are sitting here in this room, and this is my atmosphere. Okay, so in this atmosphere, there is already air particles are there, right? Like this, air particles are there. And the amount of water vapor present, vapor of water, because the air could be here, nitrogen can be there, oxygen can be there, carbon dioxide can be there, right? So a lot of gases or particles, gaseous particles are there. In between those, water vapors are also there, right? So if the amount of water vapor is already there present, okay, that means humidity is high. That day we say it's very humid today. Okay, in summer, if there is a lot of humidity, we feel a lot of, heat. We feel basically, basically it's very irritating and suffocating during summers when humidity is lot. We feel a lot of, heat. at that time. Now, high humidity means the air is nearly saturated. Saturated means something that has reached its, maximum point. Okay, like for example, your brain, you are studying right now, topic of chemistry. Now, suddenly somebody starts teaching you maths after this, and then you will study maths, and after that, maybe physics topic and biology, and then Hindi, and then English. Or maybe in an hour, you are doing all of this. And then somebody asks you, okay, do you want to learn a musical instrument or let's learn another language? You'll be like, no, I have reached my saturation point. That means I have reached the end of it, or maybe I have done enough. That means nothing more can be done here, right? So if air is nearly reached saturation, that means the spaces between air is filled with water vapor now, and it has reached its saturation point. The evaporation slow down because there is no space, right, for evaporation. So if you are drying the cloth, okay, and it is very humid that day, so it will be difficult to dry those clothes, maybe, because what happens, because here the liquid, okay, let's imagine this, the liquid which is present in your cloth, okay, this is your cloth, okay, this is C, okay, it's clothes, it's trying to go out into atmosphere and become water vapor, but atmosphere is already filled with gases and also water vapor, and there is no much space, right? So then it would not be that much possible to get like evaporation to occur, basically. So that is why clothes take longer to dry during the rainy season. That happens. Okay, so why do we feel sticky in humid weather? Basically because again there is lots and lots of water vapor around us, and also we are sweating, so and that's sweat is not going to evaporate, so then we are going to feel sticky and a lot like not so good that day, maybe. Okay, now coming to the fourth factor, that is wind speed. Now this is a very easy factor. This was supposed to be a little bit difficult. Remember this one. Okay, wind speed is the faster the wind carries away the water vapor, there will be more space, right, in the atmosphere, basically, and the particles from the surface can move easily, evaporate easily, preventing them from returning and thus speeding up the evaporation. So once, for example, I'm sweating, maybe. Okay, so water evaporated and there is space, right? And wind is there. It's windy. So they'll take the gaseous form of the water, or you can say the steam form or water vapor form, out away, right? Now there is again space near me in the atmosphere. Again, that same thing can happen. So evaporation speeds up with the wind and clothes dry quickly on the windy days. You can hang clothes where air moves freely for faster drying. Okay, so not in a room, maybe outside if you are putting your clothes, that will help you, dry your clothes easily or faster. Okay, now the last thing is nature of the liquid. Now, nature of the liquid would be liquids with weaker intermolecular forces or lower boiling points evaporate more rapidly. That you can imagine, right? So if liquids are there, that they will evaporate easily. If solids are there or something which has a lot of, force of attraction in between those particles of those substances, they will not move quickly easily. And that's why if there is weaker intermolecular forces, that is these forces which are attracting them towards each other, so those things will evaporate more rapidly. This is because their particles require very less energy to escape, so the particles can easily move away, right, and get converted into a vapor phase. Example, petrol and alcohol evaporate much faster than water. So here their intermolecular forces are very weak, okay, and that's why they can easily dry up. Okay, a nail polish remover, you might have noticed your any female friend or mother or anybody, right, is there who is a female, and if they are putting nail paints and all, they try to, even nail paints and the remover also, they try to quickly close the lid. Why they are doing so? Because the acetone is actually the weaker the forces between the particles of acetone has a very weak force in between them, and they can dry up easily. Okay, so that's why that is being done. So a fun fact is that petrol actually feels cold on our skin because it evaporates quickly, and that's why it feels very cold. So sometimes if you might have spilled petrol on your hand or something, you might have felt that. Okay, right. Okay, so cooling by evaporation. Again, this is like, 1 second. Okay. Just a second. Yeah. So cooling by evaporation is a cooling process. When liquid particles change into vapor, they absorb the necessary latent heat which is required. Okay. So latent heat of vaporization from the surroundings, making the surroundings feel very, very cool. So for example, after sweating, we feel we feel a lot of cooler than before. Okay. Even earthen pots, what is happening? The water here from the earthen pots, okay, they seep out. So these questions might ask in your exam, these, application based question. It is usually being asked. So earthen pots, what happened? The water seeps from here. Okay. The small particles of water, you can say. Okay. These pores, and they evaporate. Once they evaporate, they leave the surroundings, cooler. So that's why the water inside is much cool to eat or cooler to eat. Okay, road cooling. We sprinkle water on very hot, roads or hot, in a hot summer day. Okay, why we are doing that? Again, evaporation will leave a cooling effect. So evaporation is actually cool because it is leaving cooling effect. Okay, right. So let's quickly recap. So we have studied what evaporation is, how it is different from boiling. And we have seen how temperature, surface area, humidity, wind speed, and liquid nature can affect the evaporation. And also we have seen that evaporation shows a cooling effect. Okay. So thank you so much. I hope you enjoyed the session. And with this, we are done with the chapter. Try doing these questions. Okay. That why do we feel cold after applying a perfume? Just now I have taken the concept. So I'm pretty sure that you are able to answer it now. Why do wet clothes dry slower during rainy season? So you can put the concept of humidity here, right? And which will evaporate faster? Water in a cup or water in a plate? Again, you can put the concept of, this is just a hint, surface area. Okay. Now, so thank you so much again. Once again, thank you. And contact me through my Urban Pro profile if you want to learn more. Okay, take care. Bye-bye.